In this video, we'll use the concept of cross products to find perpendicular vectors. So here's the first problem. A vector is I cap plus j cap plus k cap. B vector is I cap plus 2j cap plus 3k cap. And we need to find a unit vector perpendicular to each of the vectors a plus b and a minus b. Pause the video, try this on your own. Okay, so first step, find a plus b and a minus b. So a plus b vector is 1 plus 1 2i cap, 1 plus 2 3j cap, 1 plus 3 4k cap. And a minus b, that's 0i cap minus j cap minus 2k cap. So we have these two vectors and we need to find a vector that's perpendicular to both of them. And how can we do that? Well, if you recall, cross product gives us that. Cross product of these two vectors will give us a vector that's perpendicular to both of them. So let's find the cross product. This cross this, a plus b cross a minus b, that's equal to determinant of I, j, k, components of a plus b, and then components of a minus b. So that's 2, 3, 4 in the second row, and then 0, minus 1, minus 2 in the third row. So let's expand this. This is I cap times minus 6 plus 4 minus j cap times minus 4 minus 0 plus k cap times minus 2 minus 0. So this becomes minus 2i cap plus 4j cap minus 2k cap. So now we have a vector that's perpendicular to both of these. But that's not the result. We need a unit vector. So how do we get a unit vector? We can divide this vector by its magnitude. This will give us the unit vector. So if you divide this, we get minus 2i cap plus 4j cap minus 2k cap divided by its magnitude. That's square root of 2 square plus 4 square plus 2 square. That's square root of 4 plus 16 plus 4. That's equal to 16 plus 4, 20 plus 4, 24. Root of 24, that's going to be 2 root 6. So this is minus 2i plus 4j minus 2k divided by 2 root 6. We can cancel the 2 out. You have minus I cap plus 2j cap minus k cap divided by root 6. So this is a unit vector which is perpendicular to both a plus b and a minus b. So are we done? Nope. There's one more vector. We took the cross product of a plus b and a minus b. So this gave us one vector. There's another vector that's opposite of this. We could have also done a minus b cross a plus b. So this will give us a vector that's in the opposite direction, same magnitude. So this will give us I cap minus 2j cap plus k cap divided by root 6, the exact opposite of this. So this is the second vector that's also a unit vector that's also perpendicular to a plus b and a minus b. Think of it like this. If you have the xy plane, your positive z-axis and your negative z-axis, both of them are perpendicular to the plane. Let's solve one more. A vector is 3i cap plus 2j cap plus 2k cap. B vector is I cap plus 2j cap minus 2k cap. And we need to find a unit vector which is perpendicular to each of the vectors a plus b and a minus b. Now pause the video, try this out. Okay, let's find the sum and difference first. So a plus b is 4i cap plus 4j cap. This cancels out. A minus b is 2i cap. This cancels out. Plus 4k cap. So we have a plus b and a minus b. Let's take the cross product. A plus b cross a minus b. That's determinant of I, j, k, 4, 4, 0. And then we have to be careful. We have 2, 0 and 4. The component of j is 0 here. So 4, 4, 0, 2, 0, 4. Let's expand. We have I cap times 16 minus 0 minus j cap times 16 minus 0 plus k cap times 0 minus 8. So this becomes 16i cap minus 16j cap minus 8k cap. Now this is not a unit vector. We need a unit vector. So we divide this by its magnitude. Its magnitude is square root of, you can take the 8 common, square root of 2 square plus 2 square plus 1. That's 4 plus 4 plus 1. That's 9. So 8 times 3 becomes 24. You can cancel this 8 out. In fact, you'll have 3 in the denominator. You have 2i cap minus 2j cap minus k cap divided by 3. So this is the unit vector which is perpendicular to both the sum and difference of a and b. Again, there's one more. We can have the exact opposite. we can take the cross product of a minus b and a plus b. So we'll get minus 2i cap plus 2j cap plus k cap divided by 3. One last problem. A vector is I plus 4j plus 2k, b vector is 3i minus 2j plus 7k, and c vector is 2i minus j plus 4k. And what do we need? We need to find a vector d perpendicular to both a and b such that c dot d is equal to 15. This involves a few more steps. So pause the video, try this on your own. Okay, let's break this down. We want to find a vector d which is perpendicular to both a and b. So the first thing that we have to do is take the cross product of a and b. So let's do that. A cross b, that's equal to determinant of I, j, k, components of a and components of b. This is equal to I, j, k, 1, 4, 2, 3, minus 2, 7. So let's expand this. We have I times 28 plus 4 minus j times 7 minus 6 plus k times minus 2 minus 12. So this becomes 32i minus j minus 14k. So this is a vector which is perpendicular to both a and b. Now we need a vector d which is also perpendicular to both a and b. Now this may or may not work for us, but all we know is this d vector has to be parallel to this vector. Because if this vector is perpendicular to a and b and d is also perpendicular to a and b, then d and this vector both are parallel. So because we want d to be perpendicular to both a and b, d has to be parallel to a cross b. So we can write d as lambda times a cross b. And we don't know the value of lambda yet, but we do know that these two are parallel or collinear. The other thing that we know is c dot d is 15. Now we can use d from here. We can say that c dot d is 15. We can plug in d as lambda a cross b. So this is lambda taking out. C dot a cross b equals to 15. Now we know a cross b and we know c. We can get the value of lambda from here. So let's do that. Lambda times c, which is 2i minus j plus 4k, dot a cross b, that's 32i minus j minus 14k, that should be equal to 15. Now we need to take the dot product. So that's lambda times 2 times 32, that's 64, minus minus plus 1, 4 times 14 is 56 with a negative sign, so that's minus 56. This is equal to 15. 64 plus 1 is 65, 65 minus 56, that's 5 and 4, 9. So 9 lambda is 15, or lambda is equal to 5 by 3. So now we know the multiplier. Now we know if we multiply a cross b with 5 by 3, we'll get d. So let's do that. Let's wrap this up. D equals to lambda times a cross b. That's 5 by 3 times 32i minus j minus 14k. That's equal to 5 times 32 is that's 160i minus 5j minus 70k divided by 3. So this is our vector d.